What's up, team? My name is Ryan, and today I'm going to present to you my contribution for the ETHDenver 2026 hackathon. This is the Zuul Gateway. The idea is simple. Agents are trustless. Prompts are not policies. So I built enforcement, that is. Zuul Gateway represents the trust layer for the agentic economy. And my favorite part, on loan from the gates of Gozer, Zuul now guards your gates. So let's go ahead and break into it. All right, so the problem, agents aren't trustworthy with keys and credentials, as we've seen with 341 malicious skills discovered on ClawHub in February 2026. So it's a lethal trifecta, right? Agents can access private data, they ingest untrusted content, they can communicate externally. You also can't tell an agent to not leak credentials and expect enforcement. Further, if there's no trail, there's no accountability. Without accountability, there's no trust. How can we trust agents? If you can't prove what happened, you can't hold anyone responsible. Can't hold agents responsible, right? So my idea is to flip the script. Instead of trying to prevent all the agents from accessing, or instead of trying to control all the agents, instead we're going to protect the castle, not the horde, right? You can't make every agent trustworthy, but you can protect and fortify your services and access to those services. If agents don't have permission, they don't get in, period. That's the idea, right? So Zuul Gateway is the solution. Zuul introduces key custody. This is nothing new, but the agent never sees the key. The proxy injects the key at request time, assuming the agent is authenticated and authorized. On-chain, Zuul also gives us on-chain RBAC, right? Role-based authentication. Permissions enforced by smart contract, not configuration files, and it also provides us with an immutable audit. Every action is logged on-chain, with providing us a cryptographic proof of intent. Agents can't leak what they never had, and with an immutable record, we now have the foundation for trust. So how does it do it? Key custody, immutable audit, permission queries on-chain RBAC, based on wallet identity. So agent identity is based off their wallet. We also provide with this MVP an emergency revoke, which is a kill switch for our agents. We'll go over all of that. So high level how it works. An agent makes an HTTP request to a tool endpoint. For the sake of this demo, that will be GitHub. When that agent makes that request, the Zuul proxy intercepts that request. It checks that agent has permission to fulfill that request using our RBAC system that is posted on chain. Assuming they are authorized, Zuul will inject the API key and forward to the tool endpoint. The tool responds, and then Zuul basically proxies that response back, and in the process, it adds an entry to the audit log on chain. Obviously, if an agent makes a request and that is rejected, they're not authorized, that gets kicked back at the proxy level without forwarding to the tool. Our per request signing gives us proof of intent for the agent's intent, and then the wallet address gives us agentic identity, regardless of chain. Okay, so let's go ahead and jump into a live demo here. Let me go ahead and clean this up. All right, so we're going to go ahead and build our contracts. This gives us two contracts, Solidity-based. Number one is the audit contract as well as the RBAC contract. So both of these will be deployed to the chain. This project supports local hard hat EVM blockchain applications. Currently, we have integrated support for Hedera as well as ADI. So we're going to do this live on the Hedera testnet. Okay, so if we wanted to, we could fire up the local hard hat instance, but we don't need to do that since we have the testnet fired in real world use. So we're going to go ahead and deploy those contracts to the Hedera testnet. This is just going to say, hey, this is already done. So I just wanted to walk this through. So now we have the RBAC Hedera testnet contract address as well as the audit address. We're going to go ahead and verify that within our ENV for the proxy. Scroll down, 1C8 and 29C. So those are already correct. Again, this is a demo, so I already have those contracts deployed to the testnet. Okay, so now we're going to know, this is a traditional RBAC system, right? So we have agent 1. This is the public address for agent 1, public address for agent 2, and public address for agent 3. 1 and 2 are internal agents for the sake of this demo. And then I also have a basic small Hugging Face small agent to actually demo this outside of the demo harness. So that is that small agent. This is the wallet address, pub key address for that small agent right here. But again, this is RBAC. The only thing that gets published to the blockchain is the agent and role capabilities. The proxy then is responsible for translating the role into the permission and authentication. So for a developer role, the permissions it has with GitHub is to read and to update. The developer role with Slack has read capabilities, and then administrator has a little bit looser capabilities, more privilege. But then our small agent, which I will show you, is also a developer with GitHub read and update access. Okay, so we're going to go ahead and publish those. We're going to register those agents with the Hedera testnet contracts right here. So agent 1 has been registered as a developer with the respective permissions. Agent 2 is the administrator, and then this is our external agent, our small agent right here. Everything has been published successfully to the Hedera testnet. So those stateful contracts are now updated. We're going to go ahead and start the proxy. Already had it running. We're going to clear that. Let's start the proxy. Make sure the cache is updated. Okay, so our proxy is running locally now, and we can go ahead and should have cleared this out. We're going to go ahead and oops, already did that. Okay, so this is just going to basically give us the agent private keys so that we can run the demo. Okay, so this is related to the developer hard hat test account. Going to run the demo. This demo is stepped. So this is the Zuul proxy demo scenario. First things first, the proxy does expose an endpoint, localhost 8080/RPC, that allows the agent to discover the available tools. This is similar to an MCP implementation, so it should be a familiar interface. So we're using the agent address 2266. That was the developer agent. Okay. So we can see here it found two tools, GitHub with read and update, as well as Slack with read. All right. So now we're going to, random number. I'm just going to put 3 just for the sake of the demo. We're going to make 3 tool call requests for this particular agent, for this developer agent. And now we're going to make, so what we're going to do now is make 3 GitHub API calls. These all should be authorized. Okay, so what's happening right now is we're making a request over to the proxy. We should see those requests come through. Where are we at? Here we go. Those requests come through, and then we get a formal response. So those were successfully proxied through Zuul, right? So Here we're accessing the repo for Claude code. When I do the small agent, I'll show you that the agents do not have a GitHub key. So custody is with Zuul Proxy. I will show you that. I will enumerate that here in a second. But for the sake of this, just to show that this does work, we were able to make 3 successful calls, read to GitHub. Summary was 3 succeeded. Okay, so now we're going to attempt an unauthorized action, which will be a post to the GitHub endpoint that should be denied. And there we go. Post was blocked as expected. Tool call failed. 403.3211 permission denied GitHub.create. This was denied not at the GitHub level, but at the proxy level because the agent did not have permission to make that call. Okay. This just shows a little bit of governance data that is available to us. And now we also have an audit trail. So each one of those calls, all 3 of those successful requests to read GitHub, as well as the failed request to create on GitHub, were all audited to the audit log. But actually, I'm sorry, before we get that, we're actually going to show the emergency revocation procedure. And that was successful. So for this, again, this is emergency revocation at the proxy level. We're not revoking the API key. For GitHub, we are revoking the agent's ability to make the request through the proxy. Again, agent doesn't have access to the custody keys, so there's no way for the agent to go around the proxy. If that's kind of a key design implementation for Zuul, or understanding is, if the agent doesn't have the API key, it's required to go through the proxy. So it's actually incentivized to go through the proxy so that it can get access to the tools that it needs in order for it to do its job, right? So here this shows that we were able to make the call successfully before we revoked the agent. Then we made the admin call to the proxy to revoke the agent. Agent revoked successfully, and then we attempted again the same call that we just attempted a little bit previously, and the tool call was denied with the 403. Agent is revoked 3212. Okay, so now we're going to take a look at the blockchain entries, and again, these contracts I've been testing on the Hedera testnet, so we're going to see a bunch of entries here, but we should see at the end of this list the fail right here. Here's the failure. Here was that success for, so this was after we revoked. There you go, the agent revoked. This is the success before the revocation, and then we had the failure test, and then the 3 successes, 200, 200, 403, 200. Yeah, it looks like we just got a timestamp issue on the blockchain, but that's okay. So here we have, a couple of key points about the audit log. The public information is what agent is basically the agent public address. This just shows that an agent performed an action. Public visibility, nobody knows what action the agent performed. They just know that this agent at this time performed an action, and then we do have a hash for provability. The payload is also stored on chain, but that is encrypted with the proxy's admin. There's an encryption key at the proxy level, so this is encrypted. So this is not public information, right? But once it's decrypted, the admin can see that. So the agent address is included, the tool that was called, the action that was called, the endpoint that was called, the status, as well as the error type, and then request hash and response hash for verification. Okay, so so there's additional API endpoints that I'm not going to go into the detail here, but we can query the audit log by agent. We saw 28 entries for that initial developer agent that I've been testing with. We can query the audit logs by an agent and decrypt it, as well as query the audit logs by a time frame. So we have success with that demo. That completes the built-in demo for Proxy. All right, we're going to jump over into the small agent. to show how an external agent outside of the demo harness can properly call a external third-party service, GitHub, via through the Zuul proxy. So just real quick walkthrough of this agent. So this is Hugging Face Small Agent. I love just how simple it is. But basically, Small Agent is calling a code agent, calls the GitHub tool. It has tasks. Get information about the Hugging Face Small Agents repository on GitHub, which repository has more stars, and which programming language is VS Code written in. Right, so it's going to do those 3 tasks. It's going to call the GitHub tool in order to get that information. Real quick, just a quick orientation here. So this is the proxy URL for the tool, so that is automatically prefixed. The agent key for signing, and then here's the headers that Zuul currently requires. So you have X agent address, which is the public key address. You have the signature of the agent for the intent of this transaction. You have a nonce, you have a timestamp. Coming over into here, you'll see here GitHub token is a token that definitely does not work. Obviously, you cannot read GitHub repositories through the API with an invalid token. I'm pretty sure you can get through with no token, but with an invalid token, it'll actually kick you out for authentication problem. And then here just registers the Zuul proxy URL. Okay, so coming back here, looks like Zuul proxy URL, and so that's that. So this agent is if it wants to call the GitHub tool, then it needs to proxy. Or it'll go through Zuul as the proxy. So we can go ahead and fire this up. Initializing OpenAI model. All right, success. Okay, so remember, in this, we had registered an agent right here, registering external agent C5B. That was developer. That was confirmed. So with the developer role, that agent has read access to GitHub. So we were able to successfully make that request through the through Zuul proxy. Okay, so we're going to go ahead and go to the next task, which repository has more stars. It makes the request through the GitHub repo right there. And that was also successful. So now we're going to go ahead and revoke. We're going to do an emergency revocation to revoke that agent. So this goes through the proxy. The proxy makes a request with the blockchain. Agent revoked successfully. Okay, so now that is now that revocation stores on the blockchain. The cache on the proxy has been updated, and then now we're going to come back and see this shouldn't work. Fingers crossed. Boom, agent is revoked. GitHub repo info. So we were using the same exact tool, and now the agent is revoked. So that is exactly what we would have expected. And then now let's come back. We got this testnet key here. We're going to go ahead and do an audit search for this agent. So we're searching the audit logs right now on chain, and there it is. We got the last two 200s, and then we got the 403 after the agent was revoked. That is exactly what we wanted. So that concludes the live demo. I kind of asked myself, how does Zuul set itself apart from Nginx or Kong that routes traffic? The trust model is with Zuul as the agent is by design untrusted. The key handling is full custody. Permissions is on-chain contract. The audit is immutable blockchain, and the identity is via the wallet signature, not an API key or JWT. So today, Zuul represents a bouncer. Trojan horses still can get through Zuul, right? So we're not technically fully protecting the kingdom, but we are keeping bad actors that do not have permission out, right? So today we call it a bouncer. Tomorrow it'll be customs, right? So the kind of a roadmap is in the bouncer state, this MVP, it's identity, it's permissions, it's the audit trail. V2 will be customs where we can do payload validation, content filtering, P detection. My background is a lot of HIPAA 2 and SOC 2 compliance. So having those audit trails is hypercritical for enterprise grade agents, and making sure that we're not leaking personally identifiable health information or anything else that might be sensitive information. Future opportunities, payment metering, right, through X402, leveraging that for payments to the service, to Zuul, for continued operations, token gated permissions, DAO controlled agents, agent to agent trust. I love the ERC 8004 agent identity, leveraging that with reputation for Zuul as well. Business model. This will always be open source. You can run the proxy yourself, but we'll also provide an opportunity to host where we run it and you can subscribe, and then there'll be an admin portal where you can manage everything, and then proper custody. What's the use case for this? Enterprise AI deployments that are seeking compliance, agent platform providers, LangChain Cloud, DigitalOcean, etc., regulated industries, fintech, healthcare, legal, Web3 agent governance, multi-tenant agent hosting. So ultimately what this positions itself is the entry point, the beachhead for the trust layer for autonomous agents. And that concludes my presentation of Zuul. Wanted to get this out for the hackathon. This is quick and dirty demo, but if you guys have any questions, please reach out to me, randalls.co. I talk about agents. I talk about Web3. This is my life. This is the world I live in. I'm a builder. I'm a product person. I'm a product leader. I love talking about the future state of the agentic economy. So much respect. Appreciate you guys taking a look. If you want any more information, please reach out to me directly, Ryan@randalls.co. Happy to chat about what we're doing at Zuul.